Welcome back. So we've mastered the Lewis structure. We can now draw and represent all kinds of small and moderately sized covalent compounds. Excellent so far. But of course the question I'm sure you're thinking about, what about larger structures? How do we draw and assemble these materials which are a bit more complicated looking? I'm pleased to say the rules are still the same. And as far as the speed, the timing that's involved, if you've done those practice problems I've asked you along with the examples we've been doing together, you've probably noticed a pattern or two emerging. You'll notice that every time you draw a hydrogen, it's simply attached to the outside of the molecule with a single bond. You may have noticed that whenever you see carbon, one way or another, it's got 4 bonds attached to it. Maybe some singles, doubles and triples, some combination, but it will take on 4 bonds. Oxygen loves 2 lone pairs of electrons and 2 bonds. Nitrogen loves having 3 bonds and 1 lone pair. And these patterns occur over and over again. That means for many conventional molecules, even if they're quite large, putting together plausible Lewis structures can actually be done quite quickly by knowing these common combinations, which means if we've got a larger molecule like caffeine, if you scout round you'll see that all of those different atoms obey these same sets of rules. So again, caffeine, your good friend that you find in coffee, your cola beverages, whatever the case may be, not too much hard work. We can go bigger. We can draw structures like this one, carminic acid, which is a relative of the red food colouring you find in all your favourite foods. We can go bigger and bigger and bigger, and all of these same rules, these same bonding styles still apply to all of these much larger molecules. So, as we draw to a close for our second module, where are we in this topic? Well, we can draw, we can represent, we can discuss different types of compounds. We know the difference between an ionic compound, where electrons are given and taken between atoms, and we know about covalent compounds, where those electrons are shared. And we know the primary motivator for atoms to form these bonds in the first place is so that they can get that stable octet. 8 valence electrons, everyone wants to be like a noble gas. So now that we can understand all of the different materials around us, it should give you a new appreciation for things you're dealing with in your day-to-day. For example, breathe in. And imagine those tiny little oxygen molecules entering your system, those 2 oxygen atoms joined together by that double bond with their 2 lone pairs. Or think about the cheap shirt you're wearing if it's anything like mine. This string of carbon, hydrogen and oxygen atoms all joined together, making up this new material. Puts a whole new spin on the world, if you like. So what are we going to do next? In our third module, we're going to start looking at chemical reactions, at chemical changes that take place around us. Naturally, we're going to take the opportunity to do a few demonstrations so you can see it, have a little fun. I hope you'll join me there. See you then.